All right, so let's talk about types of discontinuities or classifications of discontinuities. So, first of all, we have our removable discontinuities, right? And those can happen where we have a hole punched in the graph, right? And it doesn't really matter whether you have a replacement for that hole somewhere else or not, right? So if you just had a line that was like this without this extra dot there, that would still be a removable discontinuity, okay? So it's anytime you have just a hole punched in your graph, but it kind of connects on either side of that hole, okay? And so that's called a removable discontinuity. And I'll give you a couple other terms here. Sometimes people call that a point discontinuity, okay? So removable or point discontinuity. All right. Then we have our jump discontinuities, okay? And by the way, removable discontinuities happen sometimes with rational. They can happen with rational functions, okay? And they can also happen with piecewise functions, okay? All right, jump discontinuities. And I don't know if I can't think of another term that I've heard for jump discontinuities. But if you think of one or you've heard one, bring it to class. But jump discontinuities happen with piecewise functions, probably the most common. And they can also happen with, let's see, they can happen with absolute value functions. And they're not like they're kind of hybrid absolute value, so they'll have like a little more going on than a normal absolute value function, because the regular absolute value function is a v and that's continuous, but absolute value functions with kind of combined with rational can have that jump effect. All right. And then infinite discontinuities, I've also heard that, and the word that I use a lot for these is essential discontinuities. Okay, so an essential discontinuity or infinite discontinuity is where you have a vertical asymptote, right? So we have a vertical asymptote going on, and those usually happen with rational functions or reciprocal. Like reciprocal, I think would be a lot of people consider as a subset of rational. Okay, so rational functions are reciprocal functions. They can also happen with trig functions. And in particular with tangent, cotangent, secant, and cosecant. Not with sine and cosine. We'll talk about those a little bit later. All right. Now the one that we didn't talk about, and this is not very common, but we've seen it before, we've talked about it before in our class, is an oscillating discontinuity. All right. So an oscillating discontinuity, that's the one where we have f of x equals, let's see, it's sine of 1 over x, and there's a cosine, there's a similar function with a cosine, kind of a cosine equivalent. And that's the one that that we zoomed in on. It just kind of keeps going down and down this tunnel of lines, and so that's so it kind of looks like this, right? Something to that effect, where it just keeps going up and down forever as it gets closer and closer to that point, but it doesn't exist at that point, right? Because if we plug in 0 in this case for that one, then it doesn't exist. Okay. All right. So that's an oscillating discontinuity, not as common, but that's one that another type of discontinuity. We'll call that D. All right. So here are the kind of the characteristics of those discontinuities. So a removable discontinuity or a point discontinuity is where the limit exists. The limit exists from either side, but the point doesn't necessarily equal that, right? So the limit as x approaches a of f of x exists and it equals some value L, but f of a does not equal L, right? That's basically what happens with the removable discontinuity. All right. Now with the jump discontinuity, what happens is that the limits from either side are not the same, right? The limit from the left is not the same as the limit from the right, and that's when we have a jump discontinuity. Okay. All right, and then an infinite discontinuity is where we have some type of asymptote, right? To where the limit on one side or the other approaches positive or negative infinity, right? So if that happens, then we have an infinite or an essential discontinuity, and that's where we have a vertical asymptote, right?